Hello everyone, and welcome to this Diana introductory session. My name is Jean-Claude Borvel, and during the next 45 minutes approximately, I will give you a general overview on analysis capabilities of Diana finite element program and its application in the civil engineering field. And this presentation will be followed by a short demo where we are going to discuss today one of our modeling feature, which is a lofting operation. During this webinar, your microphone will remain muted to avoid any background noise disturbance. But you will have the possibility to eventually raise your questions via the question box. And at the end of this session, I will scan through these questions. And if some of them are common questions, I will reply them live, or I will get back to you directly by email or via the chat box. So having said that, let's start today's presentation. So Diana is a short form of displacement analyzer and is a general finite element program which is dedicated to all types of civil engineering, so including bridges and structures and infrastructures, geotechnical and petroleum engineering applications. Our aim is to provide a range of efficient engineering solutions to the daily or specific types of engineering problem, but by increasing by increasing the accuracy of the final results, a client could optimize the cost of their project. Our core values, the core values of our company are presented on this slide. So based on a trusted relation with our client and partners, we try to mature dynamic and innovative idea to deliver state-of-the-art solutions and quality service in a world-class product. So this is our main goal every day. On the next slides, we present a list of some of our valuable clients. We have clients in different countries, all over the world, from different organization types, from governmental organization, academic, university of research organization, but also from private sectors like consultancy companies or construction companies from different sectors, oil and gas, energy, underground structure. We appreciate their effort in trusting and using Diana in their project. With respect to Diana application, I quickly go through some of the main key features and activities. We start with geotechnical and tunneling. We have a very good integrated solutions for all types of geotechnical and tunneling application. So you can use the integrated environment of Diana for any types of tunnelings and underground structures, for ground freezings, also called the three phases analysis, for real soil structure interaction. So if you have some sort of interaction between the underground and the surrounding soil or rock, you can model it with the concept of nonlinear interface behavior, coupled groundwater flow stress analysis, slope stability, and many more. As you can see also on this slide, we have many wizards. One of them is for the modeling of pile or sheet pile, including some predefined library of parameter. So for instance, here you see some predefined section of the sheet pile wall. This is already filled in the wizard. Next to that, we have a very comprehensive solution associated to reinforced concrete and early edge behavior of the concrete cracking. That's mainly when the model and the casted concrete go through the process of hydration. For any types of concrete box girders, composite structures, could be interaction of concrete with metal or combination of concrete with fibers. For dam structures, it's also very interesting, important because of the process of casting, curing, hydration, and impounding. We also have a good coverage for design check, including the reinforcement based on the Eurocode, mobile load and design load generator, and indeed the cross-section design check. You can use it in conjunction with your bridge applications or your general structure analysis application. We have different solutions in order to give you good estimation about nonlinear response of the model without entering into the nonlinear detailed parameter input and setup iteration like sequential analysis. Temperature and stress coupling let you analysis how the concrete goes through aging. Cooling pipes is also another powerful feature that we offer in both 2D and 3D in order to control the hydration process. Crack initiation and propagation in concrete, one of the powerful features in Diana. And also fire effect, how the fire could affect the durability of the structure. Among other applications, we can refer to masonry and historical construction. In Diana, we offer different solutions at meso or macro levels. You can use Diana to model the interaction between the individual bricks and the mortar joints. For dams and dikes, Diana offers a solution. It covers all the aspects of the construction for all types of dam structures. You can consider the fluid structure interaction, dynamic effect, and also induce damage to the structure. Fire analysis is another area that, based on its importance these days, has become one of the main topics for structural checks. Diana can be considered as one of the most reliable solutions to that respect. For earthquake analysis, you can use Diana for general dynamics or seismic analysis. Among the advanced type of application, Diana is very well known in the field of oil and gas and nuclear structures. Based on the type of complexity, you can simulate 3D geomechanical depletion, borehole stability. For nuclear structures, you can analyze concrete containments or underground waste storage. Let's now say a few words about the Diana environment. For the environment, the look and feel is very natural. On top, you find, like with any Windows look-like program, the toolbar. You have the main working window where your geometry, your mesh, or your result can be displayed. If on the left, you will find the model window or the geometry window with all the information related to your model, which are defined at the geometry level. On the right side, you have access to the analysis window where you can set up your analysis in terms of analysis type and output. And also the output or result window where you can select which result you want to present in the working window. We have also the so-called properties window where you need eventually to go a little bit further and specify some specific values or access some specific information. You can always do that from the property window. Next to that, at the bottom, you have two extra windows. One is the message window, where we basically display the state of your analysis. For instance, if you are performing a nonlinear analysis, you can follow the convergence of your analysis. And I would say if basically you do something wrong or something wrong happen, basically a warning or error message are also displayed in this message box. And finally, we have the command console, which is a Python console, and it can echo every action that you do in the graphical environment of Diana, but you can also type there your Python command. So this is a very powerful tool. With respect to the environment, we deliver the state-of-the-art solution. So yeah, the graphical tool is very intuitive with various display options, advanced selection modes. It's all based on parasolid modeling functions. And it also offers some automated and robust geometry checking and repairing tools, which are actually very convenient when you are importing CAD model. In terms of meshing, we offer a powerful and automated mesh engines, both 2D and 3D, including hybrid mesher. You can generate embedded reinforcement, and there is an automatic detection of the element type in Diana. In terms of load and boundary condition, we have a full support of loads and boundary condition that can be applied on the entire model or on the geometry at the entire level, or on some at the mesh level on some part. You can define a function, and it's fully compatible with Microsoft Excel. In terms of post-processing, again, we offer a complete solution to result interpretation. For the material model classification, we have very comprehensive dialog box with various input field, where you can also include some unique aspect that can be activated in the material model. For the load combination, you can also generate a design load combination or distinctive load combination. We have a table for that. As I already mentioned, you can generate various functions, whether spatial or non-spatial, or space function. With the property window, you have a full control on the parameterizing the selected operation. And via the analysis window, you get a very intuitive environment to set up any type of analysis, including including interactive phase analysis, so you can easily check in, check out the different sets in your phase. And of course, it offers many more. In terms of workflow, we always start with the geometry definition in Dyna, so everything is based on the geometry. So once you have the geometry defined, you assign your property to the geometry again. Then you generate the mesh. Then you set up your analysis, you run the analysis, and then you check your results. So based on this workflow, it means that any change of properties should be reflected to the mesh, because it's done at the geometry level. So every time you change some material properties or physical properties, you need to regenerate the mesh so that it's transferred to the mesh. Keep in mind that everything is done at the geometry level in Diana. In terms of geometry modeling, we have many options to create geometry of your model, going from import CAD file to primitive. We have also a good number of geometrical operations, such move, rotate, scale. You can perform Boolean operation. We have a very advanced selection filter that allows you to select points, line, face, bodies. So basically, based on your selection, you can easily select the entity. We have automatic clash detection. We have convert body and sheet. We have imprint function, rotate function. You can extrude shapes, and you can also extract subshapes, and of course, many more. So all the, let's say, geometry operation that you can imagine are basically there. So if we focus a little bit on the 3D import, so you can either import your geometry from third-party CAD program, or generate your model from our integrated environment. Among the format that Dyna can handle, there is a DWG, the DXF, the STEP, and the IGS file format. You can also import a IFC file format if you are using Revit. Furthermore, if you are dealing with terrain geometry, for instance, you can import cloud of nodes and generate a Bezier surface from them. So this is also a very powerful feature, especially if you are dealing with geotech project. After importing the geometry, there is a geometry check. You can always check the tolerance and the quality of the imported shapes. You can fix them, improve them based on certain features that we have in Diana to enhance your imported geometry. So if your CAD model, which is imported, come with some issue, you can always fix them in Diana. Otherwise, if you don't want to import your model, you can, of course, generate it from our GUI using the basic tools we offer in terms of modeling primitive to create and generate your model in full 3D. So the standard primitive in 3D are the block, the cylinder, the cone, the prism, the torus, and the sphere. And all these things are classical objects that can be generated in Diana. Of course, it's not limited to 3D. You have also that in 2D and 1D. So you can generate a polygonal sheet, a circle sheet, a line, a circle, a polyline, a Bezier curve, and of course the lowest entity that you can generate is a point. And at every moment, you have access to the shape you have generated from your geometry tree. And from the property box, you can access more in-depth information about the geometry entities that you have generated. So it's always good to keep an eye on that to see what has been done. You can also perform different modeling operations, whether unite, subtract, or intersect. These are the main Boolean operation. Or you can perform some transformation, such as a move, a scale, and a rotate. You can sweep your geometry along a wire. For instance, here we have the example of a box girder, where we have a reference shape, and we basically sweep it along a grid curve, which is basically not a straight line, but a curve line. And just in one click, you can generate a very nice solid geometry using this option. You can generate complex geometry with minimum information using some smart function like lofting operation. This is something I'm going to cover today in the live demo, and based on a dam example, I'm going to show you how to take advantage of this lofting operation. Our selection window is interactive, as I already mentioned, and object-oriented, so you can directly select based on the selection filter. So whether you go for a face, edge, vertex at the geometry level, then it will only allow you to select the corresponding entity. So especially when it's very powerful when you're dealing with complex geometry with a lot of entities. Sometimes the selection might be a little bit difficult, but thanks to this selection filter, you can really pick up the entity easily. We are using auto clash detection. You don't have to worry about the nodal connectivity or the different component of your geometry interacting with each other. Diana automatically takes care of that for you, so ensuring a perfect continuity and connectivity of your mesh. There are other options in order to improve your geometry. So you can, for instance, use 2 or more sheets. You can convert body and sheet and the other way around. So these are also very useful feature. For any operation in the model with respect to the load and boundary condition, you can use the imprint option to have the trace and track of the imposed load or boundary condition acting on your reference geometry. Again, this is a very powerful feature. Other modeling operations enable you to rotate or move face or adjust your shape. So you can do that interactively in the working environment just by dragging the mouse along the different arrow representing the X, Y, Z direction, or the 3 circle representing the 3 rotation around the 3 main direction. You can select and extract then, extrude, select faces or edges once you have extracted them. So also this is very straightforward and interactive. You can do that from the working window. You can match different parts of your model with respect to each other using the align face function when you have different objects in your working environment. And there are different options. So based on this function, you can align the different objects. With respect to the functions, it can be assigned to the geometry to simulate the geometry thickness. For instance, in this example here, we defined a space function representing the thickness of the shell. This model is made of shell, and the function basically represents the thickness of the shell element and the eccentricity of the shell element. So this is also a smart way of modeling. Or you can use it to define the phreatic water level in both 2D and 3D modeling environment. This is a powerful feature in the context of geotechnical application when you want to model the water level. And among strong feature in Diana is the Python scripting and the geometry optimization with respect to the effectiveness of the model. when it's subjected to such a load, and how you can reinforce and retrofit the model because of the load distribution pattern in the model. There are many powerful features that you can induce and use in conjunction with other tools that we have in Dyna based on the Python scripting. And I invite you to check our YouTube channel. We have a couple of good technical webinars where some of our clients present their daily work and the involvement of Python in this daily work. For meshing, we have different types of mesher. These are smart processes. They recognize the generation of your geometry. If your geometry is based on extrusion, extrusion mesher comes into the picture and generate a nicely patterned structured mesh. We have adaptive element size that enables you to increase the density of nodes and elements at certain corners and edges in order to have a smooth transition mesh. So this is this option here that you see in the set mesh property. And you can see without and with the option activated, that when you have it on, you get a more dense message around the edges where basically you need a smooth mesh. This is another example where you can see the effect. If you have a terrain geometry, for instance, you can see the difference with or without the adaptive element size option. You can observe that with these options, you have a smooth mesh transition in some particular part, where without, basically, you get something very coarse and far from the reality. You can also use grading to optimize your mesh. You have a full control on the distribution of the nodes and the elements. So again, it's not a black box. The end user has full control on what he's doing. After meshing, you can visualize the type of sections that you have assigned to the model based on the different profiles that we have in our library. This is done using the real dimension, and it enables you to check the orientation and eccentricity. So this is a very nice thing, because you want to take advantage, for instance, of beam or shell models, but then you still want to have a kind of realistic representation of your model. So this is fully possible using this option. At the mesh level, you have different way of presenting that enables you to inspect or present your model in the most suitable way. So wireframe, different solid shading views, or shrinking view. So all these options are available at the mesh level. Also, there are different mesh engines which enables to generate structure or unstructured type of mesh sets. Here we have some nice examples of some map mesh or auto mesh of a complex model. Another powerful feature is incremental meshing. This is very interesting when you are dealing with complex models and you need to do some modifications at the geometry level for any reason. Thanks to this incremental meshing, you don't need to remesh the whole model. Dyna automatically goes for the meshing of the geometry parts of your model that have been subjected to the modifications. So this way you can save a lot of time in terms of meshing or remeshing of your model when subjected to change. So here, for instance, we have an example which we use in courtesy of Dr. Oriol Arnaud. It's a building which consists of 3,460 shapes, and it has 2,421 reinforcement bars. So if you mesh it from scratch, it takes roughly 10 minutes, so 623 seconds. And if for any reason you need to change something, for instance, if we touch the setting of one of the single reinforcement bar, using this incremental meshing, it only takes basically less than 2 minutes, so 11 seconds to remesh. So it's not remeshing from scratch, as I explained. So this is very interesting when you are dealing with complex structure. And at the end, we have series of online documentation, including our verification report, as well as our background theory. And of course, next to that, we have also on our webpage more than 100 tutorials explaining step by step through different case studies the workflow of Diana. So this is it for the presentation. In the next 20 minutes, I'm going to demonstrate the lofting operation. And for that, I'm going to use one of our tutorial, which is a lofting operation in Diana. This tutorial is available on our website. So the loft operation in Diana creates a sheet or a solid shape by fitting surfaces through a series of profiles. So with this operation, lines can be converted into sheets or wires, and wires or sheets can be converted into bodies or sheets. So this is very interesting. The geometry created by a loft action can be constrained by specifying optimal guide wires. We will see that in the demo. There are several options available related to keeping the input shape, converting the result into a wire, and dealing with imprints. So we will also go through these different options. And to illustrate that, we will use a double curved arch dam, which basically have a complex geometry and shapes and are usually defined by a series of simple horizontal curve lines, such arch or parabola. So in the demo, we will use the lofting tool to create a arch dam geometry, and we will also have a look at the different available options and their influence. So here you can see some element of the geometry we are going to use. Here we have basically a kind of view where we have only the faces of the crest and the base and wires of the section over the 8. And we will see how using this geometrical entity we can create basically the full dam. And to make the geometry of the dam with the lofting operation, we will consider two options. One using intermediate profiles, so all these profiles. So we will start by creating a curved line for the upstream and downstream and create a closed wire. And for the second one, we will just use curve gates to define the trajectory, and we will just create the crest and base section. So let's move to Diana. I have already a session open. So for this, I have already created a project. This, you are familiar with that now. You start a new project, you give it a name, you give a dimension. In my case, it's a 3D project. The type of analysis. Yeah, I put structural, but today I'm not going to perform any analysis. I will just show you how to generate geometry bodies using the lofting option. And so the analysis type is not that important. And we also set up our units. And in these examples, basically we go for meter, kilogram, Newton, second, Kelvin, and degree. So having said that, I'm going to create some profiles or some circular arch, let's say, for the upstream and downstream of the dam. So I'm going to do it once, and thanks to Python operation, I'm going to create the other one because I don't want to take too much of your time with repeating the same actions. So basically, I go to the circular arc option over there. I give it a name. So I'm going to start with the arc upstream, the first one. Try to give names that are meaningful for you. This one will be center in 0, 0. The plane normal is 0, 0, 1. Reference direction is 1, 0, 0. The radius will be 88.3. So for all the input data, I mean, I invite you to refer to our tutorial, which is available on our website. You have all the information there. And the radius is 98.1. So until and unless I click create, now you know that nothing happens. So I click create. Then I see that I have my entity that appear under my geometry, and I adapt the window so I can see my first basically circular edge. So I'm going to repeat that operation 6 times again because I want to create 7 arcs for the upstream side and 7 for the downstream side. So always using this circular arc operation, I'm going to repeat that. I have the Python script, so in order to save time, I'm going to copy a couple of commands to go faster. So I start with the upstream. I'm going to adapt the view so that we can see all of them. So this is for the upstream, and I'm going to repeat the same operation for the downstream. So nothing complicated, you just repeat the same operation based on some geometric criteria that you have as input. Just trying to find the best view so that everyone can see properly. My mouse is a little bit overreacting. Go to webinar. Let's say that this is it. So you see that we have a set of arc on the upstream and a set of arc on the downstream side. So now we are going to create some face for the crest using already the lofting operation. So the lofting operation, you can find it on top here. This is this option, and I'm going to create a name set which I call the crest. And here I'm going to select the two profile, which are basically the arc up one and down one. Not this one. So sometimes it's easier to select from here. My mouse is a little bit too sensitive today. I apologize for that, so I do it again. Crest. And then I'm going to select this one and this one. And then I go for the option minimal file, and I click apply. And I see that it went completely wrong. So I think I'm going to close the now. Something is wrong. I'm just going to restart. Nothing to worry. It's always the charm of having a live demo. So we are back. Let me set my Python. So here I just recreate all the geometry or all the arc that I was doing. And I'm also going to make the first loft. So I'm going to select this. Control C. This is the advantage of having a Python console. You can always restart. So here we are back. We have our different arcs for the upstream and for the downstream. So I restart my demo from here. So I was creating a crest body name, and here I'm going to select these two, the two arcs at the upstream and downstream at the crest, and I choose no specific option, and then I click apply. And then you see that I have a face which is created with the name crest. I'm going to repeat the same story now for the base. where I take the last two arc. And here you see that under the geometry, I have now the crest and the base face. I need to create now some intermediate wires. I'm also going to do that using the lofting operation, but now with a different option, which is basically the option convert result to wire. So I'm going to call it wire 1, for instance. Just trying to find the base view too. So I select this one and this one, and here I click on the option convert result to wire. So it's not going to make a face, as you see already in the preview mode. It's making a closed wire. So I click apply. Then I repeat the operation for the other level. So nothing complicated. You have to repeat it 5 times. So 2 more. We are almost there. And the last one. And then I see that here I have a missing number. I can rename. You just right click the name of the entity. So it was 1, 2, 3. And I can close this. So now I have my two face, the crest and the base of the dam, and the different closed wire. So now we have all the faces and wire needed to create the dam with the lofting operation. So let's move on. And again, I go to the lofting operation here. I'm going to create a body that I call dam. So keep an eye on the geometry under the geometry tree, under the list of shape, because this is where the magic is going to happen, basically. And here in the profile, we need to select the wire in the order, basically, in which the loft is created. So if I start with the crest, I go for 2, 3, 4, 5, and then the last one, the base. And you see already in preview mode that the solid rendering of the geometry is there. So if I click apply, I ended up with only one shape, which is my dam body. And all the, let's say, the tool shape have been removed or deleted. So you see, I mean, in just a few clicks, how you can build such a complex geometry thanks to the lofting option. So this was for the illustration of the lofting option, but now let's explore the options of the lofting operation. In this case, what happened, for instance, if I create or I do the same operation, but with the split at each profile option. So let's see. So I'm going to undo. So I revert to the previous step where I have all the entity of geometry. And now I do the dam. So again, I need to select the different profile, and always in the right order. And now I select the split at each profile. So what happened in that case? Then you can already see that we create a dam with this option. We see that the transition between the different faces and wires is not smooth anymore compared to what it was with this option off. And instead, we also see the straight line delimiting all the wire. So this is basically one of the difference when you use this option. let's continue. And for instance, what would happen if I will use the keep profile? Then I click apply. You remember that with this option off, if I click apply, I will end up with only one geometry set, which is the dam. So now I have this option on. Let's see what happens if I click apply. You see that I have my dam, but all the tools, geometry, so all the different wires and the faces that were deleted with these options off are now kept. So basically, that's the main difference with the previous operation. Let's continue. And for instance, what would happen if I use the grid face for the imprint? So I'm going to, again, do the selection. Select my different entities, starting with the crest, then wire. Yeah, I have to select. Yeah, now it's good. Not this one, this one. So 1, 2, 3, 4, 5. Yes. Here I switch off the keep profile. So the same would appear, the keep guide we will see in the next example, but it also keep basically the guide line. And here in the imprint, I go for the grid face. And you already see in the preview mode that in this case, you see the print or the imprint of the wire and the base. So if I click apply, I have one geometry, but I have the corresponding imprint of the upstream and downstream arc, and also the vertices. So it means that if I use the shape selection here, for instance, to edges, I'm able to select. Normally, it should work. Oh, I have to close this, of course. Somehow my computer has strange behavior, but believe me, with this option, you are able to select vertices, or yeah, now I can select vertices. My mouse is really behaving very strange today. So, but you are able basically to select the points or the edges of which are imprinting from the tool operation. So that's what it does with this operation. It built the dam, but also imprint the edge and vertices of the tools, so that later on you can select them, for instance, to apply a boundary condition or loads. So let's continue. And now we are going to do the same, but we are going to use a different operation. So we are going to create the dam with guides from the crest to the base face. So the guides are curved lines connected to one vertex of each profile to define the trajectory of the loft. It's a bit like with the sweeping operation, you need a grid curve. And yeah, we are going to do this type of things, but now with the loft operation. So I'm going to remove this one. And first, I'm going to recreate some arc for the crest and for the base. So again, I'm going to use my Python for the second operation. So here I have the command to create upstream and downstream arc. You can see them here. So we have the upstream, top and bottom, and the same for the downstream. Then I need to create the face. So I'm going to use the loft operation as we did before. I select these two arcs and I click apply. If I mouse allow, repeat the same for the base. So now we have our two face, crest and bottom and base. Sorry. Now I need to create my curved gate. So it's basically a curved line, but are defined by a set of points. So I have to define 4 curves, which consist each of 7 points with coordinates. So again, to save time, I'm going to use a Python command of that, which are including the different point coordinate. So you see the different curves, which we are going to use to basically build our complete dam. I was looking for the correct one. So again, we open the loft operation. We call it dam. And now here we select the true profile, which are the crest and the base. And we need to select some gate, because here you see now there's no gate selected, so it just go straight. Now I'm going to select the different curve. And you see automatically the geometry is adjusted based on the selection of this gate curve. And now I click apply, and I end up with my dam with a nicely built geometry along this curved gate. So this is another way of building the dam. The first one was based on different profile at different height. And now this one from 2 faces, top and bottom, or bottom, base and crest, using some gate curved. We can, using the lofting option, we can basically create the dam. So if I undo that and go through some of the options, again, to see what happened. So again, I select my dam, select my 2Pro section here, then my curve. What happens if I go for keep gate curve? Because we have seen that without this option, the result of this operation is one body, which is the dam. All the tools are gone. So if I click on apply now, you see that I have the dam body, but the curve are kept. So basically, it's keeping the gates that we used for modeling this dam. So this is what I wanted to highlight today, how powerful is the lofting option and how you can take advantage of the different options offered by this operation to build complex 3D geometry. So if you want to practice based on this case, I invite you to take a look on our website, on the tutorial webpage. You will find a tutorial which is lofting in Diana. It's a feature tutorial, and it covers basically the aspect that I have discussed today during this demo. So before we end this session, before I go through the list of questions, I want to quickly mention to you that we have a couple of events coming in the months of June and July, starting with our nonlinear behavior of reinforced concrete structures online courses. This will be the second edition this year. It's 6 module courses, as you are probably aware of it, because we are giving this course for many years. And it will take place from June 1st to June 17. So 6 sessions of 2.5 hours with in between every other day a Q&A session. So this is a very good course for the one who want to know more about Diana and the general capability of the software. We will have also one course session in July about groundwater flow analysis with Diana. So again, it will also be applied to a 2D dam. So for the one who are interested to know more about potential flow analysis in Diana, especially groundwater flow, you are most welcome to join. And finally, end of June, so on 29th of June, we will have a free live demo. So this is a free event where during 1 hour, I will present a case and discuss the thermostress analysis of early age concrete with Diana through the case of a purification wall. So this is a free event, so feel free to register if you want to know more about the capability of Diana regarding this aspect. So having said that, I'd like to thank you for attending this webinar. I'm going to have a quick look at the questions. So if some of you need to leave, I just want to thank you for attending this event. Otherwise, I'll get back in a few minutes. I'm just going to scan if there are questions and whether I reply them live or directly via the chat box. Thank you. So I see there are a couple of questions regarding our tutorials. Our tutorials are free, and let me show you. You can find them on our website. So if I open Internet, you go to Diana FEA. This is our website. If you go to the tab on top, Support Center, you have tutorials here. And here you have the full list of our tutorial. You can filter them by tutorial type, analysis type, or model required. For instance, if we go for the, let's say, beginner level, the getting started, and you click apply, there you can see some more simple tutorials, and you can have a kind of glance of what the tutorial is about, and you can download the tutorial from there. So basically, you download the PDF with the step-by-step explanation how to do this model in Diana. So, and I've seen that a couple of people were asking that, and these tutorials are basically available on our website, and they are public. So feel free to look at them. Let me see there are more questions that I can answer now. Apparently not. I think it's okay. So in that case, I'd like to thank you one more time for attending this webinar. It was a great pleasure to have you on board today. Please keep an eye on our website if you want to attend some of our paid courses or free events. Always keep an eye on our website because there are always new events coming up. So if you want to be up to date with the latest Diana development, yeah, just keep an eye on our website. Thank you all for attending this webinar, and wish you all to have a pleasant day. Good afternoon. Bye.